engineering thermodynamics, the basic concept of first law, the outline, form of energy, energy conservation, concept of work, PV diagram, concept of internal energy, Joule's law, thermal capacities, concept of enthalpy, various form of the first law, types of process. The form of energy, first one is a internal energy, second one is a kinetic energy, third one is a potential energy, fifth one is a mechanical energy, one is a heat energy, it's a chemical energy, electrical energy. These are the form of energy. Next one is a energy conservation. The first law of thermodynamics states that the total energy is conserved for any thermodynamic systems. Energy cannot be created or destroyed. Energy can only change from one form to another form. So work is a mechanical form of energy. Work equal to force into distance. Recall the definition of pressure. P equal to force divided by area. We can write dW equal to PdV. This is the work and thus the defines work as dW equal to PdV. Next one is a concept of work. Change in volume cause work. Work is performed when the air expand. Work of expansion occurs when a system perform work on its environment is positive. Raising a parcels undergo expansion work since the environment pressure decrease with a height. With a height, a rising a parcel must expand to maintain an equivalent pressure. These are the changes in volume cause work similar to piston in a car engines. Change in volume cases, work is performed when air contracts. Work contractions occur when a environment perform work on a systems is negative greater than 0. Sinking air parcels undergo a contraction of work since the environmental total pressure decrease with a height. With a height, a sinking a parcel must contract to maintain an equivalent pressure. pressure and volume diagrams, another way of representing the thermodynamic process concerning the transformations. We can write dW equal to PdV. The work done is the area under the I if F curve or gray areas. Next one is a first law of thermodynamics. Internal energy is equal to kinetic energy plus potential energy. Depends only on the current system's state, pressure, volume and temperatures. Does not depending on the past state. Does not depending on how the state change occurs. Changes are the result external force on the systems. Internal energy, work environment and heat environment. Du equal to minus dW plus dq. Du equal to minus pdV plus dq. Next one is Joule's law. Vacuum valve closed conditions, fully thermal insulated systems. Next one is valve open conditions. Air expanded to fill the container. Change in volume. Change in pressure. No external work was done. Air expanded into a vacuum with the systems. No heat was added or subsided. Thermally insulated systems. No change in internal energy. Thermal capacity, specific heats. Assume a small quantity of heat. dq is given a parcels. The parcels respond by experience in a small temperatures increase. dt. The specific heat C equal to dq by dt. Two types of specific heats depending on how the material change as it receives that constant volume Cv equal to dq by dt constant volume. Then constant pressure Cv equal to dq by dt constant pressures. The parcel experience change in pressures. The parcel experience in change in vacuum. Starting with Cv equal to dq by dt at constant volume. If the volume is a constant, dV equal to 0. We can rewrite the first law. du equal to minus pdv plus dq minus du equal to dq. And the substitute into our specific heat equation as Cv equal to du by dt or du equal to Cv dt. Specific heat at constant volume. Since the internal energy is a state variable and does not depending on the past stages or how state change occur, we can define changes in internal energy as del U equal to substitute our specific heat equation into a first law. du equal to cv dt, then write du equal to minus pdv into dq. We can obtain alternative form the first law of thermodynamics, dq equal to cv dt minus pdv. Next one is a concept of enthalpy. The impact, assume the heat dq is added into the systems at a constant pressure. Impact, the system's volume increase V1 to V2, and the system's internal energy increases U1 to U2. Using the first law, dq equal to U2 minus U1 plus P equal to V2 minus V1. We can define the enthalpy as H equal to U plus PV. Enthalpy dq equal to U2 minus U1 plus P equal to V2 minus V1. H equal to U plus PV, pressure volume. If we differentiate the definitions of enthalpy and use prior relationships, we can obtain the following the relations. dq equal to dh equal to cp minus dt. We shall see that enthalpy will be a useful concept since the most sources and the sinks of heating in the atmosphere occur at a roughly constant pressure. Thus, the terms of first law of the form of the first law of thermodynamics. The first one is for a gas of masses m. Second is unit masses. These are the notations for pressure, volume, temperature, specific volume, specific heat constant volume, specific heat constant pressure, gas constant, dry air, universal gas constants. Next one is types of process, isobaric process, the transformation at constant pressure, dP equal to 0. Isobaric process, transformation at constant volume equal to 0 equal to 0. These are the isothermal process, transformation at a constant temperature dT 0. Adiabatic process, the transformations without exchange of heat between the environment and systems, dq equal to 0. These are the reference. Thank you.